In this video, we will be exploring the properties of similar triangles, and we will use those properties to find unknown sides and unknown angles. Problem number 1. We are told that these triangles are similar, but we need to figure out which are the corresponding sides. I see that we have a side angle side similarity happening, so we can really just focus on which of these two sides correspond to which of these two sides. And of course, the bigger side will correspond with the bigger side. So see the 24? That's the bigger side. It's not wanting to draw for me. Hold on. 24 is the bigger side and 16 is the bigger side. So those must be corresponding. And then we have the 18 and the 12, which must be corresponding. Which by the way, of course, means that this side and this side must also be corresponding. So now, of course, we have the 42-degree angles. Those are corresponding. Now, angle J is between the square and the triangle. I'll put a single mark. See the square and the triangle, single mark. Now, angle K is between the triangle and the circle, double mark. All right, see the triangle and the circle, double mark. So now we know which angles are corresponding, so we can make our similarity statement. So triangle AJK, I'll just say the first one that way, triangle AJK is similar to triangle. Now, A corresponds with S, J corresponds with W, single mark, and that just leaves angle Y. All right, let's go again for number 2. So these triangles are similar. So if these triangles are similar, of course, angle L is going to be congruent for both triangles. Now, it looks like this side and this side are corresponding, and it looks like this side and this side, all right, the big triangle, will be corresponding. Of course, the big side would be 15. If I want to be sure, I might test out the scale factor real quick. If I go, if I treat the 12 as the new triangle, and if I treat the 8 as the old, so I would do 12 over 8. These are both divisible by 4, so that would be 3 over 2. Now, if I do the same thing, so I did the 12 and the 8, okay, so now I'm going to do the 15 and the 10, all right, for these corresponding sides. So if I do the 15 over 10, both of these are divisible by 5, and again, I'm going to get 3 over 2. So we are correct that these are corresponding sides and these are corresponding sides. So I'm going to unmark the L for a minute because obviously angle L is going to be congruent to itself. Reflexive property. So you see angle N here between the 10 and the 8, angle LNM, okay, between the square and the circle. Now between the big square and the big circle, I have this angle right here. So those are going to be corresponding. All right, we already know that L is taken care of, so that leaves these angles to be corresponding. So, and this was pretty obvious. You probably, if you had guessed it, you probably would have guessed correctly. But now we've sort of proven it. So small triangle LNM, I'll say it that way, LNM is similar to, all right, there's the L again, all right, it's the same, but N corresponds to Q. and M corresponds to P. So there's your similarity statement. Okay, problem number 3. These triangles are similar. Find the value of x, and then use that to find the value of LM and QP. So these triangles are similar. So let's figure out the corresponding parts. So these are vertical angles, so I know that they are going to be congruent. Okay, and then I'm given these sides, the 18 and the 12. Okay, oh, we're parallel lines. I was looking for more information. I see now. See these arrows? These arrows mean that the lines are parallel. So we're going to use that to our advantage for sure. So if this line is parallel to this line, parallel lines will lead to congruent angles. And the way we find those angles is by drawing the transversal and knowing that the corners of the Z will be congruent because they are alternate interior angles of parallel lines. So these are the corners of the Z. These will be congruent. But we could just have as easily have drawn the other transversal, which I will do now. All right, this transversal is just as valid, which makes a slightly different Z, which is marked here. Boom, boom, boom. Hit up with the triple, y'all. Okay. So now that we have all of the corresponding angles marked, it will be easy to talk about the corresponding sides. Okay, look at this 18. Let's go ahead and put a box around that. This 18 is between the single and the double. All right, here's the single and the double, so this is going to be corresponding. This x plus 3 is between the double and the triple. Circle. Double and the triple. Circle. So now I've matched up the corresponding sides. So, all right, this would be a perfect problem to do the proportion method. I'm looking at the two circles. They both have variables. You know what? I could still do the scale factor method. I'm still going to do the scale factor method. The scale factor method, we need to find the scale factor. Of course, I will use these corresponding sides. I'm going to consider this to be the old and this to be the new. I just randomly chose it that way. And I know that the scale factor is always going to be a new length divided by an old length. So in this case, that would be 12 over 18. Okay, and this will reduce down. Both of these are divisible by 6. So this is going to be 2/3. So that's what we will use as the scale factor, 2/3. Now, the scale factor should turn an old length into a new length. In other words, if I do 2/3 of the old length, x plus 3, that should equal the new length, x minus 1. All right, so it's just a matter of solving this equation. Now, it won't help me to multiply by the reciprocal because I would just have, I still have variables on both sides. So the best thing to do is simply to multiply by the denominator. See the 3? I would multiply both sides by 3. All right, so that way these cancel each other out. All right, so that still leaves the 2. Now I'm going to take that 2 and I'm going to do the distributive property. So this will make 2x plus 6. And the distributive property here gives me 3x minus 3. All right, now I'm going to subtract 3x from both sides. That gives me negative x plus 6 is equal to negative 3. Subtract 6 from both sides. That gives me negative x is equal to negative 9. Divide both sides by negative 1. And that gives you x equals 9. Okay, so that's one of the things that we were supposed to find. X is equal to 9. Okay, now we need to find LM and QP. So, LM, let's look at the picture. LM is x plus 3. But now we know that x is 9, so LM is going to be 9 plus 3, which of course is 12. So LM is equal to 12. And finally, we need to find QP. Looking back at the diagram, QP is x minus 1. So x minus 1. And again, x is 9. So this will be 9 minus 1, which means that QP will be 8. So QP is 8. Problem number 4. I know that these angles are congruent because they are vertical angles. But also because these angles, these sides are parallel. These arrows mean that I have parallel sides. So this side is parallel to this side. So if I draw the Z by doing this, I can see the alternate interior angles. So this angle is going to be congruent to this angle. All right, alternate interior angles are congruent when the lines are parallel. But I could just as easily have drawn this transversal to form a Z facing in a different direction. So that tells me that this angle is going to be corresponding and congruent to this angle. Excuse me. Boom, boom. Whoops, took away some of my marks. Oh, so this is supposed to be a double. This is supposed to be a triple. Okay, so now I know everything that is corresponding. So I will use that to know for sure my corresponding sides. For example, this 3 is between the double and the triple. So is the 4. That means that those are corresponding. I see that the x plus 1 here is between a single and a triple. So is the x plus 3. So those are corresponding. So I'm going to use the scale factor method. All right, I know that the scale factor formula is that the scale factor is always new divided by old. I'm going to pick this triangle to be the old and this triangle to be the new. You could do it the other way. You will still get the same answer. But if I look at it this way, then the scale factor, okay, of course I'm going to use the 4 and the 3, all right, because that's the only one where I have actual numbers for both. So the scale factor will be 4 over 3, okay, again, new over old. So now that I've got the scale factor, I can use that to make another equation using the x plus 1 and the x plus 3. All right, if you take the scale factor and you multiply it by an old value, an old side, it should give you the new side. All right? So in this case, if I take my scale factor and multiply it by the old side, x plus 1, that should give me the new side, x plus 3. All right, so it's just a matter of solving this equation. The easiest thing to do would be to multiply both sides by 3. All right, I'm multiplying by the denominator. Okay, so I'm multiplying both sides by 3. That way over here, these are going to cancel out. And then I can distribute this, and I will distribute that. So that is going to give me 4x plus 4 is equal to 3x plus 9. Then I will subtract 3x from both sides. So then I've got x plus 4 is equal to 9. Okay, I'm running out of space, so I'm just going to bring that up over here. So I've got x plus 4 is equal to 9. So now I can subtract 4 from both sides, so that gives me x is equal to 5. All right, so I found x. So now I want to find EG. All right, EG is x plus 1. But I know that x is 5, so that means that EG is 5 plus 1. So EG is 6. And I'm also supposed to find GH. Okay, GH is x plus 3. But x is 5, so GH is 5 plus 3, so GH is equal to 8. Okay? All right, moving on to number 5. Now be careful. So make sure that you are visualizing the correct triangles. You should be picturing a small triangle inside of a bigger triangle. So this is the small triangle, and that is similar to this larger triangle. Okay, these are the two triangles that we are matching up. So as I do the rest of the problem, please keep that in mind. Okay, maybe I'll leave those colors on there for another minute. Okay, I think we're gonna have to do some extra shenanigans here. All right, so there's just one trick that we really are gonna need right now. Let me get my red pen. To find side KL, if the large side is 24, and then I've got this 8, that's a little portion of 24. Then this side right here must be the difference between 24 and 8. So to find KL, I'm going to do 24 minus 8. Okay, and that's going to turn out to be 16. So this is 16. And think about it. Hold on, that's too small. So if I do 24 minus 8, all right, that's 16. Or looking at it another way, if I add 8 plus 16, all right, if I add these two smaller lengths together, of course, that's going to equal 24. So this makes sense. Okay, so that was crucial because we needed a small side, a side of the small triangle, and then we need the big side. Okay, so here is a pair of corresponding sides. So we have the small, and then we have the big. All right, I'm going to look at the small triangle as being the old triangle. And I'm going to look at the big triangle as being the new triangle. All right, that's the way I'm going to look at it. You could do it the other way, it doesn't matter. So I know that these are corresponding sides. Okay, now, for these sides over here, man, this is going to be a little tricky. Let's use this hint that we first need to write an expression for the full length of NL. Okay, so here is the full length of side NL. So we'd have to add these two together. So combining like terms, 6x plus x, that's 7x, and 5 plus 2, that is 7. So the large side of the triangle is 7x plus 7. Okay, that was crucial. So, corresponding sides. So for the small triangle, I've got 6x plus 2. All right, and then for the large triangle, I've got the 7x plus 7. Okay. So, if I do the scale factor method, so my scale factor is going to be new over old. Okay, so then my scale factor is going to be, so new over old. So that's going to be like the big one divided by the small one. So that'll be 24 over 16. That's my scale factor. Let's reduce that down. All right, both of these are divisible by 8. So this is going to be 3 over 2, but let's see what happens. 24 over 16. Oh, look at that, 3 over 2. So that's my scale factor. So remember, if I take my scale factor and I multiply by an old side, it should equal the new side. So that's what I'm going to do with these two expressions right here. I'm going to take my scale factor of 3 over 2, and I'm going to multiply by an old side, which is 6x plus 2. And then that should equal the new side, all right, which is the bigger triangle, which is 7x plus 7. Now the easiest way to solve this is to multiply by the denominator. So I'm going to multiply both sides by 2. Okay, that will cancel these 2's out and leave the 3 to distribute. So that's going to give me 18x plus 6 is equal to 14x plus 14. Now subtracting 14x from both sides, that's going to give me 4x plus 6 is equal to 14. Now subtracting 6 from both sides, that's going to give me 4x is equal to 8. So, of course, if I divide both sides by 2, that's going to give me x is equal to, what? I don't mean to divide by 2. That was silly. I mean, if I divide both sides by 4, that's going to give me 2. So now I know that x is equal to 2. All right, now I'm supposed to find nm. Let's see. nm is x plus 5. but x is 2, so that'll be 2 plus 5. So that means nm is equal to 7. And I'm also supposed to find ml. ml is 6x plus 2. But again, x is 2, so that means ml is 6 times 2 plus 2. So that's 12 plus 2. So that's 14. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.